This lesson is on sequences using summation notation, determining whether a sequence is arithmetic, and finding a formula for an arithmetic sequence and a new term. The assignment is an online assignment in MyMathLab. Sigma notation is to find the sum of the first n terms of a sequence. That is, to find a1 sub plus a2 plus a3 all the way up to a sub n. Rather than write down all the terms, we can notate this using summation notation to express the sum. As we have learned, math people love symbols. If they can write something smaller, we do. So the symbol of sigma notation takes a really long span of numbers being added together in a pattern and breaks it down into this little kind of sigma S-E-ish looking notation. This Greek symbol, in mathematics means sum or to add up the terms. The integer k is called the index. So there's a new vocabulary word there, and it's the index of the sum. The index is the number in which the sum begins, and the n is where the sum ends. So it's pretty well marked out with that information. So let's get to work and see how this kind of looks in an example. Here's an example of how to write a sum in sigma notation. This is not on the guided notes, but I thought I'd start with one that we can kind of discuss, and then we'll practice the examples 1, 2, and 3 in our guided notes. So express the sum in using sigma notation. So here's a sum. Notice how we have plus signs. Yesterday we did sequences, which would have commas in between the numbers. So one big indication that you might use sigma notation is if you have plus signs. So 2 plus 4 plus 6 plus 8. You can definitely see there's a pattern here. We're going up by 2s, and we're stopping at plus 16. So we want to write this in sigma notation. So the first thing you need to do is kind of also figure out what the generic equation is. So if we're going up by 2s, we have a slope of 2, and we want to add it up. So how many terms are there? The sum of 2 plus 4 plus 6 plus 8 all the way up to 16 has 8 terms. Each term, each of the form 2 times k, and starts with k equals 1 and ends at k equals 8. So this will take a little bit of practice to kind of get used to, but it's just writing the equation of the sum and how many terms are there. So this will look something like this. We have this giant sum, 2 times the 1, 2 times 2, 2 times 3, all the way up to 2 times 8. So the formula is going to be written in very condensed down form like this sigma notation. It just says add from k equals 1, plug in 1, plug in 8, and just like yesterday, instead of writing it out as a sequence with commas, it means you're adding the first 8 terms 1 through 8, and you're plugging in 1 through 8. Only integers can go into the function. Okay? This next example is in our guided notes if you choose to use them. It also has an asterisk on it, so there's an author in action video if you also want to watch the author explain this. So question A has them write out, it's in both of these are in sigma notation. They want to express as a sum using sigma notation. So this has, notice, an n in the top bar. So this is saying express the sum that does not stop. So we just want to establish the pattern. So you're expanding it out. So if you know what an accordion is, then you're going to expand out the accordion and write out the expanded form of this formula, k over or divided by k plus 1. So the first one, you're going to plug in 1 into the first piece and get 1 divided by 2, and then make sure you have a plus sign, 2/3 plus 3/4 plus 4/5, and then please use the dot dot dots notation plus, and then write the nth term where you plug in n, which will be n divided by n plus 1. So that's important notation that shows that the series is going on until the nth term. I encourage you to pause the video and try part B. All right, part B has k squared minus 1. So this is a quadratic form of the pattern. You saw one of these yesterday in the examples where you had to write this equation. So it's a tricky one, but the best way to establish a pattern is to expand it. So you're going to start by plugging in k equals 0, k equals 1, k equals 2, until you get to n. So please use the dot 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 and then plug in n for the nth term. And it will look something like this: -1 plus 0 plus 1 and so forth plus n squared minus 1. So then the last term you're going to substitute the variable n, signifying that that's the nth term. In example 2, we are trying to write the sum of the sigma notation for 2a and 2b. I also have example 3 on here where we're trying to expand and evaluate. All of these again are on your guided notes if that helps you to follow along with them and write them down, or you can write them down on a simple sheet of paper. In part A, we have to come up with the formula. We did this in yesterday's notes. but we had commas in between these patterns. And so now we're still doing that, but now we're going to write sigma notation in front of that pattern. So in this pattern for part A, the numerators are all 1, the denominators start at 1 and go up by integers of 1, and all the quantities are squared. So it looks like we need to have a quantity squared with a 1 on the numerator, and since it's going to be our index k, it looks like we have to start at the number 1. So the sigma notation should be k equals 1. There are 5 terms if you count them up, and so it goes to n equals 5 up on the top. All right here is 5 for n, and then it's 1 over k quantity squared. So this right here is the formula of the pattern or sequence, and then all we're doing is putting the sigma notation in front to show that we are summing up the first 5 terms. It's much cleaner looking and takes up a lot less space. Imagine if it wasn't 5 terms and it was 105 terms. This is a way to condense it down into simple math notation, and again, math people love notation. I encourage you to try to write the sigma notation for part B on your own. Okay, so part B goes 1, 3, 5, so hopefully you can establish the pattern there. They actually give you 2n minus 1, which means they're giving you the explicit formula for this pattern. It's a linear pattern going up by 2's, and the 0 term would be -1, and we'll talk more about that. It's actually a special pattern. It's called arithmetic. So the sigma notation means k equals 1 all the way to the nth term, because we don't have it terminating, and then the formula 2k minus 1. Again, k could be changed out for a different variable. I is common because it's the index. I've seen t for term, but k is what our book standard started, so we left it as k. All right, example 3 is in a condensed down version. We kind of already saw one of these out, but it's indicating that we want to write out the first 7 terms as a sum. So you do need to use plus signs with that. So we're going to sub in 1 through 7 into 3k plus 1. So just like yesterday, but again, instead of commas, we're using plus signs in between their notation. So we would calculate out 1 through 7 and put plus signs between that. So please try that. And you should get 4 plus 7 plus 10 plus 13 and so on. And the sum should add up to 91. Now, it's pretty tedious to add all these up on the screen of our calculator every time. Again, there's only 7 terms, but what happens if there were 70 terms? So the calculator has been programmed to be able to add up sigma notation and allow you to add up lots of things very, very quickly. So we are going to work on that in this lesson. How do we make the calculator do the math for us? Okay, so that it sums it up. So what we need to do is we need to go to our math button and press the button 0 for summation, and it even has a little sigma notation. If you have an 83 or an older model of 84, you may not have this under math options. If that's the case, on the next slide, there's a video for students who have to use an 83 or an older version of 84 and do not have summation notation. If you do have an older version, I encourage you, and an 84, I encourage you to go to the IT Texas Instrument webpage and actually download the newer iOS to your 84, because it's very, very helpful for this and very helpful for calculus. Okay, so we're going to go to summation notation and we're going to add up those values. So we're going to type that in, and then the screen on your main screen should look just like it does up above, and you would just type in the k, the 1, the 7, and the equation 3k plus 1. So please try that out and see if you can get 91. This slide's only for students with an older calculator of a TI-83 or the older operating system of the 84. So if you already have the newer one and were able to do the last example with the sigma notation, then you can skip this slide. This one, the video is linked at the bottom for the YouTube and will be accessible through our calendar under today's date. All it's going to have you do is take this sigma notation k equals 1 to 8 for 5k minus 12. It's going to have you go to second stats for the list, go to ops, sequence, to have you type in a lot for the coded information, and then you'll go back and hit the sum. Hopefully almost no students have this older 83 or 84, and if you have any issues, please feel free to email me. This next tab is for everyone, but it's on the theorems. We will do a lot more of this later in the chapter. It shows you how to add, subtract, and work with a constant value through sigma notation. So you can look at this for now. It's also in your book, but it will come in future lessons. That should be it for sequences of sigma notation and information for today's lesson.